Here we go, mathletes. Welcome to 3.6, the chain rule. And the chain rule is, besides probably the power rule, probably or one of, or maybe along with the power rule, one of the most utilized rules in calculus, so or with derivatives at least. And so the chain rule, what it says basically is if you have a function within a function, so if you have a g of x function as the input of f of x function, right? So a function within a function, then when you take the derivative of that function, if that function is called h of x, where you have f of g of x, this means the same thing, right? This is called sometimes this is called Fogg notation. So, but this means f of g of x, and this is kind of a more intuitive, in my opinion at least, way to kind of express a composition of functions. But if that function is called h of x, if you take the derivative of h of x, then basically you take the derivative of the outer function, the f function, and you keep the input the same, and then you take the derivative of the inner function, and you multiply that by the derivative of the outer function. Okay, so it's derivative of the outer function multiplied by the derivative of the inner function. Okay, and it also works with Leibniz notation, which we'll talk about a little bit more in depth later on. But basically, you can take the derivative of y, a y function with respect to u, by multiplying the derivative of the u function with respect to x. So basically, if you have a function of u of x as kind of your inner function, then you take the derivative of the outer function y with respect to u, which is the inner function, and then you take the derivative of u with respect to x. Okay, so it basically means the same thing, but it's just another way to write the same thing. So this is the derivative of the outer function multiplied by the derivative of the inner function. Okay, and this is the way we'll kind of write it, at least to start out. Like I said, we might use Leibniz more later on in the chapter. Now let me just kind of show you an example of why this is useful, and just to show you what a function looks like that would utilize the chain rule. So here we have a function, and you can see that we have a function inside of a power rule, right? Inside of a function raised to a certain power. So we basically have a function within a function. So the g of x function would be the polynomial inside there, the 2x cubed plus 2x minus 1, and then the outer function would be the raised to the fourth power, right? So the f of x function would be the exponent, the raised to the fourth power there. And this would be problematic, right? Like if I was using the skills that we have now, we don't really have an answer for how to find the derivative of that, right? We could multiply it by itself 4 times and then use the product rule, but that would be pretty tedious, right? That would be a long process using the product rule 4 times. So that would be one way to do it. We could also expand this and FOIL it out, or super FOIL really, because there's 3 terms in here. So we could expand it and make it into a really big polynomial, and then derive that, which the derivation would be pretty easy to find the derivative, but the work to expand it would be a long process, right? And so anyway, so now we have a way to do this pretty simply, and you'll see that here in a little bit. We'll actually do this example, and you'll see how to be pretty straightforward, pretty easy compared to those other ways, at least. All right, so here's just a kind of a strategy or a procedure as far as using the chain rule. And so the first thing is we want to identify f of x and g of x, right? Kind of like we did on that example problem, right? So we want to find the f of x function, the outer function, and then the inner function, right? So f of x will usually be the outer, and g of x will usually be the inner, although That doesn't have to be that way. You can use other letters if you want as well. Okay. And then what we're going to do is we're going to find f prime first, and then we're going to input g of x into it. Okay. And basically, you won't necessarily have to. You'll just find the derivative and just keep the input the same, basically. Okay. And then we'll find g prime of x, and we'll basically just multiply those two things together. Okay. We'll multiply f prime of g of x, and then by g prime of x. Okay. All right. And so we go outside in for the most part. So here it says, keep in mind that we work our way from outside function in. Okay. So we go outer to inner, and then so think of it as if we have a composition of two functions, then we have two parts, and we'll talk about a third iteration later on where we have three parts, and then we'll have that means we'll have if we have three functions that are composed, then the chain rule will have three parts, right? We'll have another times h of x, right, or something like that, h prime of x. Okay. And then also remember that we don't evaluate the derivative at a derivative. So in other words, like, it's not going to be f primed of g primed of x, right? Like, that's not how this works. Okay. So notice how g prime on the inside stays the same. So when we take the derivative outer function, the inner part doesn't change, and we'll see that in our examples.